computer. Oh, okay. Well, all right. Okay.
Everyone knows.
Everyone knows who the one who cares about everybody is. Is that what it is? Okay. there's no something dumb, but okay. All right. So let me just find it, because I could have been wrong myself. So let me. Hi, folks. ITS128. Today is February 5th, 2019, and we are. This is February 5th. So, let me share my screen. I will do that right now. Sharing my screen. Share. Close this. And imaging. It is in the images. This is 128, right? All right, so some gentleman in this class asked a question about where you find images. If you go to resources, now I'm not sure. I'm gonna check. I'm gonna sample programs, image. No, it's done. But, okay, let me go. Oh, I know images. Not this images. This images. And I go click on images. Let's open this up. And let me just pop this bad boy on the desktop. And let me go to the desktop. And let me right click and do extract all. And images, coins. All right, here's some coins, some coinage. I actually, for my other class, this was such a good problem. I actually have this very similar problem in the other class. And so let me go there. Now, what exercise was it in the other? What do I have here? Ooh, I got these. Okay. All right. I want to do this. Dime. Ooh, that's a nice dime, isn't it? Let me save this. How do I do that? Oh, let me go back to here. Oh no, no. In this class, it's heads and tails, right? So I just have the heads of all these. The heads. All right. So isn't that a nice image, though? I found that on the web. On the web. All right. So anyway, forget it. Yeah. So in the heads or tails in this class, here it's this one. So you do that pretty bad looking head and that pretty bad looking tail over there. So anyway, so today we are, let's go back, oh, wrong class, overview, resources. We are in February 5th. It looks like we're starting chapter 4. So I get to do my, I get to do the chapter 4 slides, don't I? So let me go to resources and click on PowerPoint slides, and it would be chapter 4. So I'm going to click on this, and I'm going to put this down in this special location that they give me here. Why do they call it thaw space? Save. All right. So and there's an assignment. So I added a new assignment. And so this is what the assignment is. And basically it is, this was not a good, I should have put the other one up there too. In fact, I think all right, I'll put it up later, but basically let's go to vital source. Oh, for those of you that have the textbook, you all should have the textbook. You all should have some version of the textbook. Let me sign in. My password. Yeah. And it is actually, I actually took this one from the textbook. So we are in chapter 4. Chapter 4, the end, programming problems, accept and close. It's actually this one here, this color mixer. It's exactly this. So the assignment is almost exactly this, except for what? Oh, okay. Oh, what is this? This one? Oh. Hold on, you folks at home, hold on. Okay, anyway, so I had to fix the screen. All right, so in this question, in this problem, we have the colors red, blue, okay. The colors red, blue, and yellow are known as the primary colors, red, green, blue, red. Ooh, no, never mind, it's a different kind of primary colors. There's primary colors if you add, and there's primary colors if you do something else. So like on monitors, it's red, green, blue, but for mixing paint, I believe it's red, blue, yellow or something. I don't know. So anyway, but let's just do what this problem says. The colors red, blue, green are known as the primary colors because they cannot be made by mixing other colors. When you mix two primary colors, you get a secondary color as shown here. So we have, if you mix red and blue, you get purple. If you mix red and yellow, you get orange. And if you mix blue and yellow, you get green, turns out. Create an application that lets the user select two primary colors from two different sets of radio buttons. And the form should also have a mix button. And when the user clicks the mix button, the form's background should change to the color that you get when you mix the two selected colors. So this is what the form should look like right here, color mixer, and you select the first color, and you select the second color, and you click mix, and the background should turn to that color. That's kind of what I have here, except for I've added one thing. I've added this thing down here where you got to say what the color is in English. Why? Because not everybody can see colors, okay, duh. So, you know, to some people, no, I'm not colorblind, so this looks green to me, but for some people it might be something else, I don't know. So I want you to put that there too. It's the only thing that's different. And so in this particular example here, if you click the red button, or you click the blue button, click the yellow button, and you click mix, then the thing turns green. Before it looks like this, and then you click the mix button and it looks like, you know, this. And then the word green appears down there. That's all you gotta do. Okay, so so that's this assignment. So so I'll probably do this assignment. Let's see, this overview. I think we're spending 3 days on this. Spending 3 days on this chapter. We'll see if we take all 3 days. So I'm gonna and there's a couple ways that we can accomplish this. We can use nested if statements, or we can might be able to use a switch statement too. And we're going to learn in this chapter what these are. So we're going to learn about decision structures and the if statement. We're going to learn about the if-else statement. We're going to learn what nested if-else statements look like. We're going to learn about logical operators, because when you're testing to do if you should do something, you know, you have what are called Boolean expressions, and they're big long expressions, and the result is either going to be true or false. If it's true, you do one thing. If it's false, you do another thing. So it's kind of like, you know, if the first color is red and the second color is blue, then you do something, you know, else. So if first color equals red, you know, that's going to be true or false. Second color equals blue, that's going to be true or false. And then you want to do and they're both true. Or maybe you're going to do, if one of them is true, they both don't have to be true. You know, that kind of stuff. It's exactly like Excel when you use if statements. Except for it's a little bit easier in the programming languages, because in Excel, lots of times you have to use like a function where you do something and put in parentheses, and that's yeah. And then I guess we're going to learn about how to prevent data conversion exceptions with the try parse. Have we talked about try parse yet? Yeah. Okay. So I could have covered that already. Input validation, and we're finally going to learn about radio buttons and checkboxes. And the switch statement, in the very end, we're going to cover list boxes. So, you know, in this chapter, we're going to learn about 3 ways of accepting input besides the buttons: radio buttons, checkboxes, and list boxes. And we can actually fiddle around with this assignment here using any one of them. Okay. In fact, if you use checkboxes, you can end up with a very interesting solution to this, where you don't need 2 sets, you only need 1 set. But anyway, we will cover that later. Right now, let's grab down. Let's check out these. Where is my thaw space? This PC. Thaw space. Alverson, chapter 4. Let's see, just make sure I am recording and I'm sharing my screen. All right, chapter 4, topics: decision structures and the if statement. Then we're going to talk about the if statement specifically: nested, logical, Boolean variables, and flags. A Boolean variable can just take on 2 values: true and false. George Boole was an Irish minister, Irish priest, I guess. They'd be priests, I guess, in Ireland. And but he was a philosopher and a logician and everything, and he came up with this. He's the one who actually formalized it and made the mathematics from it. So it's named after him. And comparing strings, we're going to learn how to prevent data conversion exceptions using try parse, which we've already done. And validating input, we use it to validate input. And then radio buttons, checkboxes, the switch statement, and list boxes. So decision structures. A control structure is a logical design that controls the order in which statements execute. Sequence structure is a set of statements that execute in order. Decision structure execute statements only under certain circumstances. If something is true, you execute the statements, otherwise you don't execute the statements. So only if a certain condition exists. We also can call it a selection structure. So this is the flowchart way of looking at a decision structure. I'm actually taking this class at KCC because I'm taking it, I don't have to teach a class. Kind of cool. So I'm taking a class, I don't have to teach a class. And what it is I'm learning the absolute correct way of designing an online course. And when we design online courses, it's a little different because when you're doing face-to-face courses, you can just I'm going to be a little revealing here, and it's like you only have to stay a couple days ahead of the students, and but you can't do that in an online course. You have to know exactly where you want to end up in the end, and you got to divide it all up right, and you got to set it all up, and you got to be very careful about your student learning outcomes, as they're called. Got to break those down into module learning outcomes. And so I sort of was contemplating this because flowcharts used to be how we always design our code first. It's kind of like first you got to design what you want the thing to do, and then you got to code it, then you got to write the program. And we always used to express things in flowcharts at first. And that was kind of a carryover from, in engineering, you have the design schematics and everything, and so it involved drawing. You had to learn how to draw. And I remember when I was in engineering school back in the 70s, we had to take drafting classes and stuff because we had to draw stuff. And then some bright guy named Warner, and bright folks, academic folks named Warner and Orr came along, and they thought, well, gee, why don't we use nesting to sort of describe it? Because nesting, you can just do something like this. This is like nested. It's kind of funny. And then you can just write it, typing like words, but then by nesting what's inside, you sort of expressing this kind of thing, this where code. If it's cold outside, then you do what's inside these braces here, otherwise you don't. And if it's cold outside, you wear a coat, otherwise you don't do anything. And we don't use flowcharts anymore for anything other than entry-level computer science classes, kind of, pretty much. But it's a good way to visualize it. So we do cover flowcharts a little bit. I've included it in my course outline for the this online course that will go into effect next semester, not this semester. Those of you at home that are taking this course online, some of you are, about half of you are, you're lucky, or maybe you're not lucky. But after this, when our programs become more complicated, it gets too crazy to try to express our code in these visual diagrams. Also, in an online class, how do you hand in a flowchart? What? Am I going to have you draw the flowchart and snap a picture of it with your phone and upload that? I could do that. I mean, I do that for other stuff, but it's going to be more like I show you a flowchart and then you write the code for it or something like that. So you still got to understand how they work. But flowcharts are so obvious. You just have to learn what these symbols, how these symbols are, what they're supposed to represent. But just by the arrows that go in and out of the symbols, you can figure that out. But anyway, so for this thing, you know, the generic if statement looks like this. Also back in the old days, we didn't have any kind of indentation or anything. You could not indent. The statements all had to start in column 7 of the punch cards. I mean, you start the statements later than that, and the computer, the card reader didn't understand what you're doing. So if you wanted to show any kind of, you know, logic visually, a flowchart was the way to do it. But anyway, so you'll notice this cold outside. It's either going to be true or false. Well, that's a Boolean expression because there's only two outcomes. It evaluates to either true or false. And so that's what happens inside this expression word right there. You have a Boolean expression. Now, we'll see later that Boolean expressions can be pretty complex. And you can have Boolean expressions where they're made up of sub-expressions that are not Boolean. Like you have one sub-expression and you evaluate it and it equals 5. And then you have another sub-expression and you evaluate that and it equals 10. And the question is, in the middle, does the first one equal the second one? Or does the first one not equal the second one? Or is the first one greater than the second one? See, so you have these operators that can take, and they are called relational operators, and they can take, you know, 2 sub-expressions on each side, which evaluate to something not necessarily true or false, although they can be true or false. Because of this relational operator, the overall result, you know, the complete result of the full expression is going to be true or false. So these are the relational operators, and we've got greater than, less than, greater than or equal to, less than or equal to, or not equal to. And it turns out, we will reinforce this later, that if x is greater than y, that's the same as if you switch the x and the y and you make them in the opposite order, then you would use this one. You know, you can put this x over here and put the y over here, but then you change it to the other one, greater than, less than. Also, you learn that if x is greater than y, it's the same as okay, if it's true that x is greater than y, it's the same as, is it not true that x is less than or equal to y? So in another sense, this x greater than y and x less than or equal to y, in another sense, these are opposites. Because if this is true, whenever this is true, this is going to be false. Whenever this one down here is true, this one here is going to be false. So in a way, there's the opposite. Those are opposites. And of course, these are opposites. If x is equal to y, then it's not true that x is not equal to y. So anyway, this is the flowchart way of the statement. If sales are greater than 50,000, then you get a bonus of 500. Otherwise, you don't get anything. Otherwise, in the case of this particular flowchart, if sales is not greater than 50,000, then bonus is undefined. It's not that bonus is equal to 0. So that's kind of a flaw in this. You actually should have, that's a picture. You should actually start out with something like bonus equals 0, semicolon. This should be a lowercase b, lowercase b, and let's do it. I'm just being silly here. Courier. Query or new. Bold, bold. You never have to apologize. You're welcome. Apology accepted. All right, anyway, so you really should have something like this, because then when you're down here, bonus has a value either way. But anyway, I'm just being critical. All right, so that was, so this is an if statement. So it's just, if something is true, you do something, otherwise you don't do anything. You also have if else statements, where if something is true, you do something, otherwise you do something else. So either way, you're going to do something, and based on the truthiness of the expression here, this is called a Boolean expression. You either do statements, these statements, or these statements. Okay. So if else will execute one block of statements if its Boolean expression is true, and another block if its Boolean expression is false. It has two parts, an if clause and an else clause.
The other one, where it's just the statement?
Yes.
Where does it go if it's false?
It skips. It just skips. Yeah. Just goes down here. Something. So either way, blah will equal 1, 2, 3. But when blah is equal to 1, plus bonus. Some dumb thing like that. Okay, so this is the if then else. I'm sorry. Okay, so I'm going to make a mistake and say if. So many you'll hear this all the time. I will inadvertently put the word then in there. Okay, because in many languages there's a then. There's the word then after this. It's if then, if something, then something else. And so in many languages it's called if then else, because there's the then part and then there's the else part, and either the then part gets executed or the else part gets executed. But in this language, you don't use the word then. There is no word then. It's just if else. So just apologizing to you up front for that mistake. Almost every language has the word then in there. All right, so this is the flowchart way of illustrating the if-else statement. So the if part, the block of statements that comes immediately after the if is display hot, it's true. The else part is what is executed should the expression evaluate to false. So if it's not true that the temperature is greater than 40, then you do this display equals cold. So if it is if the temperature is greater than 40, then it displays the word hot. Okay, this is clearly not Hawaii they're talking about. Otherwise, it displays cold. Now, what I was saying earlier is if you change this, if you change it to if temp is less than or equal to 40, okay, if you change that, if you change this symbol here to less than or equal to 40, here, let me just steal this thing here. So it can be this is the same as if temp is greater than or equal to, no, I'm sorry, less than or equal to 40, parentheses, then you'd say message box show code. Else. So this is sucky because it always thinks it knows better. And these should be up and down quotes and not fancy quotes. But anyway, so you can see the symmetry here. It's like if you change this to the other one, then you reverse the true and the false. Anyway. Okay, now we can also nest these decision structures. Over here, we talk about a block of statements. Let's go back to this one. We talk about a block of statements and a block of statements. Well, this block of statements can be any kind of statements, and it can be if-else statements. So that's why you can have if. You can have the block of statements here. You can have another if-else. You can have another if-else, and so you can end up with something like this, where you have if this is true, then go on and do some more ifing. And otherwise you just do these statements. So you can say, if it's hot, or if temperature is greater than 40, okay, so then you go down here. If it's raining, do something, otherwise do something, or down here, or I don't know, if it's, you can think of why you would wanna, if something is true, well, then we don't have all, then we got to decide something else. If we're gonna, if it's Sunday, then, or not then, if it's Sunday, if it's true that it's Sunday, then if it's morning, we go to breakfast, or I don't know, something like that. If it's morning, go to breakfast, instead of if it's morning, then go to breakfast. So nested means we're just nesting. You can get what that means, one inside of the other. And in C#, the generic form looks like this. It turns out that you can have, well, anyhow, we'll get to that. And so this is what the flowchart might look for this. If your salary is greater than or equal to 40,000, then you do something else. Let's say you go into the bank or someplace and you want to borrow some money, whatever. To buy a car or whatever. If it's not true that your salary is greater than 40,000, then they say, sorry, buddy, we discriminate against poor people. You cannot have a loan. If it's greater than or equal to 40,000, then they want you. Hey, come on in, come on in. By the way, how many years on the job have you had? Oh, 1. Sorry. We changed our mind. We don't want you. So here we have this nested if-else inside of a if-else. And you see, when we're done, we end up in the same place. So this is how you would write it. In this case, we have a label and and we aren't using a message box. We're using a label, which is going to be on the form someplace. And this is probably going to be maybe a text box, which you type in something and hit a calculate button, and it will display out. The label will display one of these things. Now, turns out that you can use that. It turns out that these if-else statements can be more complicated. You could do something like this, where instead of just if something is true, else this, instead of that, you can actually, have more than one test. So something like this. And so let's say you're calculating your grade, this is whatever your grade or whatever, you enter in some numerical value in here, and if it's greater than or equal to 90, you display out an A. Else, if it's greater than or equal to 80, it displays out a B. Else, if it's greater than or equal to 70, you display out a C. Else, if it's greater than or equal to 60, you display out a D. Else, you display out an F. And so as you go down, you sort of eliminate possibilities. And so that's why right here, in here where you're saying if grade is greater than or equal to 80, you know that if you're here, that if you get to this point, this grade, if you get to this test, you already know that it's not greater than or equal to 90. Because if it were greater than or equal to 90, you would never get to this point. You only get to this point if it's less than 90. And so in that case, you only have to test if it's greater than or equal to 80. And then down here, you know that if you reach this test, you already know that that's gonna be less than 80. It's gonna be less than 90. It's gonna be less than 80 because if it were not less than 80, it would never have gotten here. So the order in which these are written, of course, matters. And maybe when you took ICS 101, you had to somehow express this in Excel, and you end up with a really hairy nested if all in one line with a bunch of parentheses and everything. And so anyway, that's that. Now it's kind of funny because in some languages, the else if is collapsed into one word, without the E. It's kind of weird. Anyway, all right, so this is called the if-else if statement. And you can have as many of them as you want. All right, so now we have these logical operators, and just like we have arithmetic operators, plus, minus, multiplication, division, we have logical operators and an or. And as you would guess, and you take two expressions, one expression here on the left, which is going to evaluate to true or false. And then you have another expression here on the right that's going to evaluate to true or false. And you have this and operator. And of course, if it's and, then they both have to be true for the whole expression to be true. With the or operator, only one of them has to be true for the whole expression to be true. Conversely, I think that's the right way to use that word. If one or none of these is true, then this expression is false. In this case, if neither of them are true, then this expression is false. And then we have this single, it's called a unary operator because it only takes one, it just takes one operand. You evaluate this, it's going to be either true or false. And with this with this exclamation point in front of it, you change it to the opposite. So it's sometimes called the not operator. Oh, it is what's called the not operator right here. So it negates or reverses the value to its opposite one. And, or, and not. Now, just as an aside, does it say that here? I don't see it. You know that with arithmetic operators, there's a thing called operator precedence, and multiplication and division have precedence over addition and subtraction, no matter where they are in the expression. If you got this big old long expression that's got a bunch of multiplications and divisions and additions and subtractions in it, and there's no parentheses, then you look at the expression and you first you evaluate all the multiplications and the divisions first. You do all that first. And then after you're all done evaluating the multiplications and divisions, they're not there anymore. You've collapsed them into values. Then you go do the additions and subtractions, and then presumably when you're done, you don't have any more operators anymore. So the operator precedence is multiplication and division have precedence over addition and subtraction. And similarly with logical operators, the AND has operator precedence over the OR. So if there's ANDs and ORs in an expression, you do the ANDs first, and then after that you do the ORs. Also, the unary operators in arithmetic expressions would be a plus sign in front of a number or a minus sign in front of a number. You know, like -5, it's got the minus in front of the 5. That has operator precedence over everything else. So if you got unary operators in there, like you're saying -5, well, you do the -5 first, and then you'll do the multiplications and divisions or whatever. Same with the not operator. The not operator actually has precedence over everything else. So the first thing you're going to do is the not operator, which is why you got to put parentheses around this one, because if you didn't, if there were no parentheses, then you'd be doing not x. Is not x greater than y? And that wouldn't make sense because not operates on a Boolean value. Not operates on a true or false. And in this case, you know, this greater than operator operates on 2 arithmetic values. And so if you didn't have parentheses, this just wouldn't make sense, because this would have, you know, precedence over this. So anyway. All right, so for example here, we say if the temperature is less than 20 and it's been more than 12 minutes, then the temperature's in the danger zone. So in Minnesota last week, if the temperature is less than -60 and minutes is 1/2 of a minute, then you're probably dead. Okay, then for the OR operator, if the temperature is less than 20 or the temperature is greater than 100, then the temperature is in the danger zone. So it's too cold or it's too hot. If it's in the middle, the temperature is not in the danger zone. All right. And the not operator here is if temperature is not greater than 100, or if it's not true that the temperature is greater than 100. In other words, if the temperature is less than or equal to 100, then it's below the maximum temperature. So not is like changing this one to less than or equal to. So if not temperature is greater than 100, it's the same as temperature is less than or equal to 100. So There's actually all kinds of things. There's things like with the anding too. Like if you make this the opposite and you make this the opposite and you make this and, then it ends up being the same thing. Huh? Yeah, yeah. If it what? Okay, let's see if this is right. Okay, it's close. Let me do it up here or something. Oops. Let me just. There, that's this thing. So what I'm saying. Let's see if this is right. We'll just work through it. If temperature is greater than or equal to 20 and temperature is less than or equal to 100, then message danger. Is this right? Okay, if temperature is greater than or equal to, and no, that's not right, is it? Temperature is greater than or equal to 20 and, oh, is not danger. Okay, so we got to do this. If not, there we go. So I have to put one more not in there. So this is the same as this. You see that? This says if the temperature is outside this range, if it's outside this range of between 20 and 100, inclusive. If it's 20 to 100, inclusive. No. Okay, 20 to 100 is the safe zone. Outside of 20 to 100, which is what this is outside 20 to 100. Okay, here we are saying this is the safe zone. So if we're not in the safe zone, then we're in the danger zone. This says directly if we're not in the safe zone. The safe zone is under 20 and over 100. It's not between 20 and 100, 20 and it's not in between 20 and 100. It's outside that range. So this correctly expresses outside the range of 20 to 100. This correctly expresses the range inside 20 to 100. It's greater than or equal to 20 and it's less than or equal to 100. And then this negates it. Now, you're not ever going to have to know this. I mean, I'm never going to test you on this, but I'm just letting you know this, that there's always more than one way of doing something. And if I ask you to do something and some of you do it this way, but some of you other guys do it this way, I'm going to have to be witty enough, have my wits about me to go look in there and make sure that it's right. So the guy that showed all these, that showed all the stuff was true. The guy's name was De Morgan. So if you ever hear of De Morgan's theorem or De Morgan's rules or whatever, they're talking about this. So here we have the not operator. All right, Boolean variables and flags. You can store values true or false in Boolean variables, abbreviated bool. So you declare variables. You know how we were declaring variables int or double or decimal. We can declare bool, and bool are variables that can only take on the value true or false. And so we often call them flags because it's either raise the flag or don't raise the flag. A flag is a variable that signals some condition exists. So if it's false, it doesn't exist, and if it's true, it does exist. So in this case, this would be a Boolean variable because it's obviously it's the only variable inside of the parentheses of an if. I'm about to sneeze. And so if grandmaster is true, then it's you add 500 to your power level. Otherwise, you would this is the opposite. If you're not a grandmaster, only add 100. So you could have an else here if you wanted to. Okay, so we can compare strings. Various ways of comparing strings. Two ways. If we're only testing for equality, in other words, if two strings are exactly equal or they're not, then you can use the double equal operator just like you can with arithmetic expressions. However, sometimes if you want to test if or you can use this string compare method, and so this, if you use this string dot compare method, you put the two operands in there, and if this thing evaluates, if they're both equal, this method will evaluate to 0, and in which case this test here is the same as this test up here. So this test is the same as this test. So what's the advantage of using compare? Let's see if it says. It doesn't say. The advantage of using compare is if name one comes before name 2 alphabetically, then it evaluates to -1. If name 1 comes after, or if it's higher, if it comes alphabetically after name 2, then string compare is going to be greater than 1. It's going to be +1. So in this case, Mary comes after Mark. Mary is greater than Mark. So this actually evaluates to +1, which is not 0, so it still works. Okay, this is where we use try parse, and this should be LE. And the way this works, so we haven't talked about try parse yet. Okay, so we've used it? All right. Well, this is the generic syntax for try parse. What it is we're taking some value, which is a string, and a string can be something that we read from a text box. You know, when somebody types in 55 into a text box, they aren't typing in the number 55. They're typing in the character 5 followed by another character 5. That's 2 characters. That's not a number. It's two characters. However, you may want to use it like a number, and to use it like a number, you have to parse it. And so try parse is one way of parsing it. And so we have to say, so I want to try and parse this into an integer, okay? And if it works, stick the value in here. If the parse is successful, stick the value in here. If the parse is not successful, it turns out that it's going to put a 0 in there. Now, the other thing about try parse, what's nice about try parse, is this whole thing will evaluate to something. This whole thing will evaluate to true if the parse was successful. If the parse was not successful, that whole thing will evaluate to false. What that means is you can put this whole thing inside of an if. So it's like if it was successful parsing, then go ahead and use this variable to do whatever you want to do with it. If this whole thing evaluates to false, that means what this is not an integer. It's got some letters in there or something else. It's not an integer. Or maybe it's got some decimal points in there or something. So it didn't work. So then the whole thing will evaluate to false, and then you got to do something else. You got to say, hey, idiot, type in an integer or whatever. Don't type in something else. So the out keyword is required because it says that this thing is going to pass out a value, an integer value, in fact, if this does, in fact, look like an integer. So when you use double triparse, it means you want to convert this into a double type number. If you use decimal triparse, it means you're looking for that to be a decimal number. If it actually is, it's going to put the value in there. If it's not, it's going to not put the value. It's put 0 in there or something. So here's an example. Here's how we use it. How we use it in an if. So first we have to make sure we declare this thing as a number, as the kind of number, and then so if it's got to be an integer because you're going to try to convert it into an integer. In this case, it's got to be a double because you're going to try to convert it into a double and put it in there. In this case, you got to declare it as a decimal number because if this works, you're going to put the number in there and you're doing decimal, and it's going to put in the decimal number in there. And so we can use that for input validation. We can use this for input validation, where we put all these things inside a triparse because we're reading some input, and we can't make any assumptions on how intelligent the user is, and so we have to check to make sure that the user, you're asking for hours, and the guy types in a lot or some dumb thing like that, and you gotta say, come on, whatever. So that's why you have these triparses, and that's all called input validation. There are various ways to do input validation, and this is the best way because you're able to catch the error without anything. You catch it right away. And then you're able to do something like display out an error message. Whereas if you just try, if you just like read it and you try to do a calculation with it and it's not a number, then your program bombs. So, you lose control over your program and it bombs. And, you want your programs to be robust. You want your programs to work even though the user, misunderstands something. So that's that. All right. So after this, we're going to do. So now we get into radio buttons and checkboxes. Here's radio buttons. Here's checkboxes, and we'll of course we'll get way more into this later. But of course, the difference between radio buttons and checkboxes is with radio buttons, you can only check one of them. So if in this case you decide you want to check basketball, then football is going to go away. It's one. It's only one. So you can only have one favorite sport. If these were checkboxes, then you can check more, like pizza toppings. You can have both pepperoni and cheese on your pizza. Okay, so when you think about our assignment, the assignment, you got first select the first color and select the second color, and if you select the same color both times, it's going to just be that color. So we could have checkboxes where in one set of checkboxes, except for you got to figure out what to do when they check all three of them. Probably look that up on the internet. So this talks about the radio button control. There's a text field which says what the text is, and then there's this Boolean property. So you test there's a Boolean property called checked, and that checked is going to be equal to true or false based on whether the thing is checked or not. And that's the same with checkboxes. So this is how you do it. You got this radio button, and there's this checked property. It's either going to be true or false. So you can do it this way, or you can do it this way. Okay, this is the more convenient way because this thing evaluates the true or false. This thing takes it and tests if it's true. It's the same thing. But you don't need to do it the second way. But lots of times you do just for clarity. And checkboxes are the same, except for you can have more than one checked at the same time. So anyway, so we'll cover the usage of checkboxes, and we'll talk about the switch statement, which is kind of like a fancy if-else. You do something like this, but they're more complicated than that because you got to have this break in there, and if you don't have the break in there, then funny things can happen. And the default is like an else, and so this deserves a good 15 minutes to talk about. So so I think I'll leave it there. Are there any questions? Anybody have any questions? Questions? All right, so we will see you on Thursday. Thanks for watching.